So today let's solve this problem, painting the walls. So first let's understand the question. You are given a zero indexed integer arrays, cost and time. So they will give you cost and the time, and a size of n representing the cost and time taken to paint n different walls respectively. So you are given n walls and we need to paint it in such a way that it will take some cost and it will take some time. There are two painters available, a paid painter that paints the ith wall in timer units of time and take cost units of time, and there is two type of painters. First one is the paid painter and the second one is a free painter. For the paid painter, if you want to paint the ith wall, you will take time ti units of time and you will take cost of a units of money. And for the free painter, if you want paint for the for one wall, if you want to paint for the one wall, you will take 1 unit of time, but you will not charge any. So, and free painter can be used if and only if the paid painter is already occupied. Like suppose if the paid painter is free, then we can't use the free painter. So we need to return the minimum amount of money required to paint the n walls. So let's understand this small example. Here he has given 1 2 3 2 and the time 1 2 3 2. Suppose if you paint the first wall and the second wall, how much cost it will be? It will be 3. How much time it will take? 3 units of time. To paint this third one and the fourth one, to paint the third and the fourth, how much time it will take? 2 units of time. Now 3 is greater than 2, so we can say that answer is 3. I will explain it with a short example. Suppose if you see this, here time is 1, 1, 1, 1, and if we consider first painter and second painter, how much charge it gonna be? 5. And how much time we will take? 2 units of time. For the other remaining 2 walls are left, how much it will take? 2 units, but we are getting cost 5. Suppose if we consider first and the fourth, how much cost it is? 4. And to cost this remaining 2, it will take 2 units of time. We have already 2 units of time occupied by the paid painter. Free painter can paint the remaining 2 units of wall, so it is 4. So what is the minimum in this 2? 4 is the minimum, so we need to return the 4. And if you see this question properly, if you see the constraints, and cost of length is 500 and the cost of is 10 power 6 and time can be 1 to 500. So if you observe it carefully, we can see that it is similar to 0 by 1 knapsack. Why does 0 by 1 knapsack? Here we don't know, like we can't grow greedily, right? Suppose if suppose it is 2 and it is 2, and if we consider these 2, we are getting the minimum, and if we consider these 2, we are not getting the minimum. If you want to greedily or if you want to sort, it will not work out, because if you sort it, suppose if you think if you sort according to the times, suppose the time here is maximum, so I am taking suppose 5 units of time. If you sort according to the time, and but the cost is, suppose you have 10 units and here you have all the 1 units, you have 5 units of time and the 10 units of cost. How much it will be? 10. Suppose if you consider this all, how much time I will get? 4 units, not even 4 units. If we consider only these 3, we will get 3 units at the cost of 3, and with the 2 other units, and a free painter can paint these 2 walls. He can paint the wall which will take most of the time freely. So with this we can say that if we sort according to the times or if we sort according to the cost, we cannot solve this problem. We can't solve it greedily. So let's think about DP, and I think it is a variation of 0 by 1 knapsack. Here we will include or exclude. These are the only 2 categories, and then with a slight variation. Suppose if you see this is the main function, and suppose if we start from here 0, 0, and we will increment 1, we will increment 2, and we will increment 3, and if we reach 4 at the final index, we will return maximum, and here also we will reach the final index. Here also we reached the final index. So 1 minute. So this need to be pasted here. Right. This cost, this is 2 units. So cost is 2 units, and 4, 3 we are returning 1a 10 power 9. Here we are getting 1a 9. And suppose if you see this at the second index, if you want to consider this 3, we will add 3 plus, we will add 3, and we will increment it. It will become 3. It will increment 3, and how much time it will take? Suppose your time is 3 plus 1. Why we are doing 3 plus 1? If you see it carefully, if you observe carefully, suppose we have 1, 2, 3, 4 units of time. If you are considering this, t units, this need to be excluded, right? This is done by the paid painter. By taking t units of time, what we are writing the base, what would be our base condition? It will be s is greater than or equals to n. We are returning the 0. We don't want to make it more computational, because if you consider this, what is the other option we can do? We can take a time variable or count variable we can take, and we can increase the count. And if we do this, what it will happen? Our dp size will obviously increases by 500 times, because t can be up to 500. To avoid that, what we are doing is, for t we are adding t and we are adding 1, because if you can include this is already included. Suppose if this will be painted by the free painter, that's why if we include 1 time, we are incrementing it by 1, such that other free painter can able to paint that. See, s plus t of I plus 1, we are incrementing it, and this 4 is greater than or equals to n. So we are here it will return 0. And here we will return 3. What is the minimum? 3 is the minimum. In the same way, you can do this side and you can do this side. If you observe it, you will understand. In this way, we will get the 3 as the minimum. If you see the code, directly we are using a solve variable, and in this solve, if we are not including it, if we are not taking it, we are directly incrementing the index. If we are taking, we are adding the cost, we are adding this cost, and we are incrementing the index, and we are incrementing the time as well. Time s plus t of I plus 1 because we want to paint the free painter's wall as well. And if you see this, the two variables are changing, this index variable and the time variable, and we are storing in the dp array, and the dp array can be maximum it will be 501, and the time would be until 1000 in the worst case scenario. In this way we can solve this problem. So what would be the time complexity? Order of multiplying of these two. So thank you for watching the video.